In question 5, the sum of the first and second terms of a geometric progression is 50 and the sum of the second and third term is 30. We have to find the sum to infinity. Now, the sum to infinity is given by the formula a divided by 1 minus r. So we need to find the value of a and r and then find the sum to infinity. Now, as the sum of the first and second term of a geometric progression is 50, so the nth term of a geometric progression is given by a r to the power n minus 1. For the second term, it will be ar to the power 2 minus 1. So that will be equals to ar. So the second term is ar. We know that the first term will be equals to a and the third term will be equals to, so third term will be equals to ar to the power 3 minus 1, which is equals to ar squared. Now, as the sum of the first and the second terms is 50, so we can make an equation. So that will be a plus ar will be equals to 50 and the sum of the second and third term is 30. So the other equation will be ar plus the third term, the second term plus the third term will be equals to 30. Now taking a common from the first equation, we can write it as a bracket 1 plus r equals to 50. So a will be equals to 50 upon 1 minus r, 1 plus r. Now substituting this value into the second equation, in place of a, we'll substitute 50 upon 1 plus r. So this will become 50 upon 1 plus r multiplied by r plus 50 upon 1 plus r multiplied by r squared equals to 30. Now, as 1 plus r is a common denominator, we can cross multiply it with 30. So we'll get 50r plus 50r squared will be equals to 30 into 1 plus r. Expanding and simplifying, we'll get 50r plus 50r squared will be equals to 30 plus 30r. Bringing the 30 and 30r on the left hand side, so we'll get 50r squared plus 50r minus 30r will become a plus 20r, and this 30 will come on this side and become a minus 30 equals to 0. Dividing the equation by 10, simplifying this, we'll get 5r squared plus 2r minus 3 equals to 0. Factorizing this, we'll get 5r squared plus 5r minus 3r minus 3 equals to 0. Taking 5r common, so this will be r plus 1, and taking 3 common, we'll get r plus 1. Simplifying this, we'll get 5r minus 3 and r plus 1 equals to 0. So the two values of r will be 3 upon 5 and r will be equals to minus 1. Now, as r cannot be negative 1, so if in that case, all the terms would have been the same with opposite signs, which means that the value of r will be equals to 3 upon 5. So once we have the value of r, we can find the value of a, as a was equals to 50 upon 1 plus r. So we can write a will be equals to 50 upon 1 plus 3 upon 5. So that will be equals to 50 divided by, so taking the LCM, that will become 5 plus 3, 8 upon 5, or 50 will multiply by 5 and become 125 upon 8. Once we have the value of a and r, now we can apply it to the formula for sum. So sum to infinity will be equals to a, which is 125 upon 8, divided by 1 minus r, which will be 1 minus 3 upon 5. Simplifying this, we'll get 125 upon 8 divided by, so 5 minus 3 will become 2 upon 5. Now, to simplify this fraction, we can directly substitute it into the calculator, or we can just write it as 125 upon 8 divided by 2 upon 5. And when we bring in the multiplication sign, so this will become 125 upon 8 into 5 upon 2. So this will become 5 upon 2. And this was, so 5 plus 3 was 8, 125 upon 8. So the value of a was 125 upon 8, and this was 5 minus 3, 2 upon 5. So a was, so there's a small mistake over here. The value of a was 125 upon 4, as 50 into 5 was 250. So this was 250 upon 8, or it should have been 125 upon 4. So over here, this should have been a 4 up here. So this would be 125 upon 4. Substituting 4 up here, so this will become 125 upon 4 multiplied by 5 upon 2. So 125 into 5 is 625, and 4 multiplied by 2 will be 8. So the final answer for the sum to infinity will be 625 upon 8.